Okay, now what could be the control objectives in case of hybrid electric vehicles? Because we are talking about a specific application, right? Motor vehicles. So what I want to do is I want to meet the power demand of driver. I want to operate each component with optimal efficiency. Each component means I'm using variety of components. Like for example, I'm using engine, I'm using generator, I'm using motor, right? I'm using battery. So I want to use, I want to ensure the optimal usage of all these components. I want to recapture braking energy as much as possible. And then at every point during my journey, I want to ensure that the SOC of battery remains at its acceptable level, right? Why? Because if the SOC is on lower side, say for example 34%, 40%, then I may not obtain the peak performance from my electric powertrain. So for that to happen, I always want to ensure that my SOC should always be in the topmost bracket. For example, 70%, 75%, 80%, or at least more than 60%. So that is one of the control objective, right? Okay, fine. Now let me take a look at this because the time constraint is there in front of us. We have got around 45 minutes I can take now. Okay, because that will decide to what depth I can take you through. So on this slide, you see a plot. So on the horizontal axis, x-axis is vehicle speed. On the y-axis, there is power. So here the topmost part is basically a positive power, which means we are talking about traction. And then this lower part, basically we are talking about braking, right? Negative traction, that is braking, right? And then here some 4 points I think you can see, which have been named as A, B, C, and D, right? So these are two representative points, right? Two representative points A and B in the traction region, and C and D are in the braking zone. So what this plot communicates is, if you look at the power requirement, if you look at the power requirement at point A, right? So power requirement is a bit huge here, more. So it will not be possible for me to meet the power requirement of point A through only engine generator. I will have to rely on power which I get from PPS as well. So PEG stands for power from engine generator. PPS stands for power from battery. So I would need power from both, that is engine generator as well as PPS battery, right? If I want to meet the requirement, power requirement at point A, right? While if you look at the point B, the power requirement is less. What it means is it is possible for me to take care of this power requirement with the help of only engine generator. Even I may not be running the engine at its peak level, right? So partial load under my engine probably would be operating at partial load conditions, not full load conditions, right? So this is something that the idea here is to bring to your notice, that when the vehicle is running on the road, the situations are dynamic. What it means is, right now at this instant, probably I'm going on a flat road. The next moment it would be a slope, negative slope. So I would be coming down, my power requirement will be lessened. And then after a few seconds, maybe again I would be moving up the gradient. So my power requirement would again change, and now I will demand more power, right? So point is, or sometimes I would be making a trip with full load. Sometimes I would be making a trip with no load, right? So point is, it's not static in nature, because we are talking about vehicle application, and that's why the dynamic conditions we need to realize, right? And the power requirement is dynamic in nature. It is going to change at any given instant of time, right? Similarly, at point C and D in the braking zone, if you think of, if you take a look at, my braking power requirement is huge here at C. So in hybrid electric vehicles, again, I will be using regenerative brakes as well as service brake, but my regenerative brakes alone will not be able to meet my power requirement at point C. So I will have to call upon the regular service brakes as well, in addition to regenerative brakes. And that's how my power requirement at sea would be taken care of. So I will need both usage of both brakes, regenerative brake as well as mechanical brake. While at point D, my braking requirement is not very high, which means in this case, even though I use only, even if I call upon only regenerative brakes, that would suffice, right? Because it will be able to take my power requirements. So point is, my power requirements are changing, my braking requirements are changing. Traction power, it could be traction power, it could be braking power. And with the help of control strategy, I want to ensure that my power requirements of driver should be met appropriately. And moment to moment, they are changing, right? And the ultimate objective is that I need to ensure that I make optimal usage of all the components like my engine or battery or electric motor or brakes, whatever. So as far as series hybrid is concerned, I can have variety of operating modes. For example, hybrid traction mode. Hybrid traction mode means I'll be deriving power from both sources. That is, I'm using the power which has been stored in the battery, but at the same time, I would be running the engine, thereby running the generator and trying to charge the battery. So this is hybrid traction mode. Peak power source alone traction mode. My engine is stopped, but then I'm relying on the energy that has been stored in the battery. So that's why it is called as peak power source alone traction mode. Engine generator alone traction mode. So battery is drained. So I will have to run the engine and generator, and thereby I produce the electricity and I supply it to the electric motor. PPS charging from the engine generator, which means the battery is being charged with the help of engine generator. And then regenerative braking mode. My vehicle is moving forward, apply the brakes, and that's what is called as regenerative braking mode. So these are some possible operating modes with the help of, in case of series hybrid drivetrain. Now this is where the beauty of hybrid lies, right? We are talking about variety of operating modes. That is not possible with, say, for example, conventional vehicles, or even that is not possible with, in case of electric vehicles. So this is the flexibility that we get, which owes to the hybrid powertrain, which means more than one powertrain. Now, when we talk of control, right? So that control algorithm or control flowchart is very important, right? So how we are going to make a decision. Typically, as I said earlier, also in case of hybrid, also isn't it? We are going to use a lot of electronics. So there are sensors and there are actuators, but then based on sensors, we need to produce accurate signals for the actuators, and how one is going to deal with this question, right? So this is where the control algorithm comes in the picture, right? So of course, we can have variety of control strategies, make to make, model to model, right? Depending upon the type of vehicle, the application requirements, right? One is free to devise its own control strategy, right? However, the point is it should meet these control objectives, right? So there are a number of control strategies, but just so as to give you an idea, so as to give you, the feel of these control strategies, I have presented this control strategy, which is called as max SOC of PPS control strategy, which means here the aim is to ensure that the battery SOC, that is state of charge of battery, always remains at its peak, right? That is at the heart of this control strategy. So how the algorithm runs, how the control strategy works. For example, here, the first decision that we will have to make is whether or not we want traction. If we don't want traction, of course, we'll get into the braking region, right? So inputs here are traction power, the commanded traction power, the traction power that is desired, and the braking power that has been commanded by the driver, right? So if the traction answer to this question is yes, so you get into this direction, right? So yes, if traction is demanded, then your system should use this input engine generator power, right? And then it should check whether this engine generator power is greater than or it is less as compared to traction power? If the answer to this question is no, that is the engine generator power is less than traction power, then of course we will have to use, which means the power, available power is not sufficient, which means we will have to go for hybrid traction, which means we will have to go for engine generator as well as battery, right? But in case if this is okay, if this is true, that is the engine generator is in a position to provide more power as compared to the traction power. If the answer to this question is yes, then I will check the SOC, which means one thing is sure now that I am going to use the engine. But then to what extent I will be using the engine, to what load, whether I'm going to run the engine at full load conditions or part load conditions, right? So that will depend upon my SOC status of battery. So if my SOC is less than the SOC of top, say for example, I have allocated the maximum threshold of 80%. And right now, at this moment, the SOC of my battery is 60%. What it lets me know is the battery needs further charging, right? So if this is true, if SOC is less than SOC top, if this is true, then I need to take care of my battery charging. If it is not the case, already the battery is fully charged, which means my engine generator alone traction, right? Which means there is no need to charge the battery, and engine generator would take up, would do the rest of the things. So this is how the decisions should be made if the traction is required, the traction is desired. In case if traction is not desired, which means the driver has pressed the brakes, he has applied the brakes, right? So point is his braking requirement, P brake, right? P brake means the braking power commanded by the driver. Who is commanding the braking power? Driver. And how much is maximum braking power available? This is P max. So again, the comparison would be made. If the commanded braking power is more as compared to maximum motor power, the regenerative power that could be made available, then of course we'll have to go for hybrid braking, which means along with regenerative braking, we will have to use mechanical brakes as well. But if this is not the case, that is the maximum, the motor power is more as compared to the commanded power, simply we can rely on regenerative braking. So this is, this one, the no regenerative braking, it is nothing but here we are talking about point D, while here we are talking about point C. This flow is representing point C and this flow is representing point D, right? So this is how the typical control strategy will work. So this is just an example that I have come up with, max SOC of PPS control strategy. Or the another one is, so there could be complicated control strategies. There could be very simple control strategies as well. For example, here as has been shown, this is engine on-off control strategy. So what is the idea here? The idea here is you switch off the engine and consume the energy that has been stored in the battery, right? But when it comes to, when it reaches, the battery reaches to its lowermost threshold, then what you do is you would switch on the engine, right? You would switch on the engine and then you would charge the battery. So you charge the battery, again, the battery has been charged and it has reached to its maximum threshold. What you do is you switch off the engine generator, and then you rely only on battery. But since you are consuming the battery, the SOC would decrease. It will reach to its lowermost threshold, say for example 20%. So SOC is 20%. You again start the engine and the battery SOC will keep on rising. Again, you allow it to reach to its maximum level, and then you stop the engine generator. You use the battery. So this could be a very simple strategy that also could be used. So what I mean to say is, there could be simple control strategy, there could be a bit complex control strategy, but that will depend upon the requirement, the application requirement, the kind of vehicle, the drive cycle that is relevant to that particular vehicle, right? Based on these aspects, one would devise the control strategy. Okay, fine. So this is the control scheme for parallel torque coupled hybrid drivetrain. Now here, as has been shown, right there at the center is this vehicle controller. Now this vehicle controller is going to get the signals from accelerator as well as brake, right? Because the pedal movement is being sensed with the help of, say, for example, potentiometer, right? And then the vehicle speed also is going to be sensed along with the SOC of PPS, that is battery SOC. So these are some inputs the vehicle controller is going to get, right? And then we can think of two modes, traction mode and braking mode. But then the common here is the motor operation, because electric motor is going to contribute to traction mode as well as it is going to contribute to braking mode as well. So when we think of traction mode, of course, we'll rely on engine. So here we have this engine power command through engine controller. It would go to engine. Engine will run and deliver the power. This power would be delivered to transmission, right? And then here we will take the power from electric motor as well. And here the summation of power will occur and it will go to the wheels. While in case of braking, what happens is, of course, electric motor will contribute in the form of regenerative braking, but then the mechanical brakes also would be called for operation in case if the braking requirement is huge, the braking force is huge, right? So in this, so that's why mechanical brake controller and mechanical brakes will come in the picture. And then collective braking power, that is the regenerative braking power from electric motor and braking power from mechanical brakes. So these would be coupled together and then it would be applied to the wheels. So this is the overall control scheme to show the overall control scheme for parallel torque coupled hybrid drivetrain. As you see, again, in case of parallel also we are going to have different operating modes. For example, motor alone propelling mode, which means only motor is propelling the vehicle. Hybrid traction mode, which means the both powertrains are being used, motor as well as ICE engine. PPS charge mode, which means the battery is being charged. Engine alone propelling mode, which means we are relying on the ICE engine power plant, right? Regenerative alone brake mode, only regenerative braking is used, and hybrid braking, that is combination of regenerative and mechanical braking, right? So again, I just want to bring it to your notice that there are multiple modes of operations that are possible with hybrids. And that is again the beauty of hybrids. And this is possible because we are talking about two powertrains, ICE engine powertrain as well as electric powertrains. Okay, fine. Now, again, this is very much similar to the earlier one. In this figure, the plot is trying to demonstrate you that again for parallel, in case of parallel hybrid. So far we are talking about parallel hybrid. Now we will talk about, series hybrid earlier, right? Now this is with regard to parallel hybrid. But then again, the point to be realized, to be understood here is the power requirements will again change. For example, this plot or this plot is showing the curve is showing, or rather this straight line is showing the motor, your maximum power with electric alone traction. So the power that is being delivered by the electric motor, and then here the power that is being delivered by the ICE engine at full load conditions, the power that is being delivered by the ICE engine but at part load conditions, right? And then this one is showing you the hybrid mode, that is the power that is being obtained from engine as well as electric motor. But the point again that has to be focused upon is the power requirements will vary. The power requirements are not same, and instant to instant, moment to moment, the power requirements as well as, so it could be tractive power, it could be braking power, but the power requirements will keep on changing, and this need has to be addressed by the hybrid electric vehicle with the help of its control strategy, right? So again, I think since due to the time constraint, I will not get into this control chart, right? But then what I want to show here is, so this is again a control strategy, max SOC of PPS control strategy, but now we are talking about parallel hybrid drivetrain. So earlier one that I showed you, isn't it? So this one, this is for this was for series hybrid, wherein the engine is not directly taking up the road loads, it is not contributing to the road loads. But here in this case, the max SOC of PPS control strategy as applied to parallel drivetrain, right? So parallel means we are using engine so as to take up the engine loads as well. And that's why here you see the electric alone traction mode has also now come up in the picture. And that's why here we will have to take a decision, and that decision we will take depending upon the vehicle speed. So vehicle speed, whether the vehicle speed is less as compared to VER, where VER is a reference speed, right? So point is, up to certain RPM, the engine operation may not be economical, right? Up to certain RPM, the or up to certain vehicle speed, that is the lower bound speeds, maybe say up to 20-25 kilometers per hour, engine operation won't be much economical. It makes sense to use electric motor, right? And if this condition is true, if the V is less than VER reference speed, right, then it makes sense to use electric alone traction mode, which means we will rather use electric motor and not start the engine, right? But when the vehicle speed is increased, if the vehicle speed is high, say for example the vehicle speed, desired vehicle speed is say 50, 60, 70, 80 kilometers per hour, and then it makes sense to go for ICE engine. So that is the time when I would realize that the engine operation, right? So electric alone traction mode we can see here, engine alone traction mode also could be seen here, and in between we have got this hybrid traction mode. So basically what I want to do with the help of control strategy is I am going to make a choice which traction mode is to be used, because as a human being, I cannot leave this decision to the driver. On real-time basis, the driver will not be able to sense all those dynamic conditions, the vehicle requirements, and he will not be able to make the appropriate decision. So on his behalf, who is supposed to make these decisions? On his behalf, the controller is supposed to make these decisions. On what basis? So what kind of decision? Whether to use electric alone traction mode or hybrid traction mode or engine alone traction mode, right? For example, say for example, when your hybrid vehicle is going through a crowded city area, or say for example there are certain zones where say there are government offices, or there are hospitals, there are schools, colleges, right? So point is, we want very silent operation, right? Probably these are no ICE engine zones, and especially that is the case with some advanced countries, advanced nations, right? So we would like to use the pure electric mode in that case, right? That is one scenario. And second scenario is, say for example you are accelerating on the highways, you are moving at very high speed, right? Already you have touched up to 80-90 kilometers per hour, and then further you want to increase the speed, and that is when you want to use the hybrid traction mode, because you want more power, and that's why you want not only to rely on electric mode or engine mode, but you would like to use hybrid mode. And then another situation wherein, say for example, your battery SOC is not much, the battery has been depleted, and then it makes sense to use engine alone traction mode. Or then say you are just coasting, or you are moving at more or less constant speed. That is the case with highways, right? So there the engine operation becomes economical, because you are not the speeds are not fluctuating, you are not using brakes time and again, more or less the speed is constant, and then at that time probably the best way to go forward is to use engine alone traction mode. So there are multiple modes that are possible: PPS charge mode, engine alone traction mode, hybrid alone traction, electric alone traction mode, and then out of braking again 2 modes, only regenerative or hybrid. So out of these 6 modes, which mode should be used, right? And that will depend upon the situation, that will depend upon the condition, right? whether you are accelerating, whether you are moving at the same speed, whether you in which part of city you are, right? So based on that, the appropriate mode has to be chosen, and that is what is at the heart of any control strategy. So I hope that it makes sense with you. I think I'm reaching out to you, and you are getting the idea of the control strategy part of it, right? Okay.